Hello, I'm Pandemic Frank, and this is Corona Television. Hello everyone, welcome to Pandemic Studios. I'm COVID Frank, and this is my plague beard.
Howdy, I'm Frank from Tennessee, and we don't like staying inside.
Hi, I really am Frank Lamb. And introductions are one of the hardest things to do in video recording. As you can tell, I'm just kind of messing around here with my Camtasia recording software, and I am going to talk about some simulations today, both simulations using hardware, factory simulations, and internal to the PLC program itself. Some of you who've been to my old facility may remember my mini factory. This was built out of extrusion, and it took me probably a year to build. One of the cool things about this mini factory was that it had several PLCs on it, and I could take the cables from one side and control different parts of the simulation. So there was a machine control part of the simulation, and there was a process control side. And I had a Compact Logix from Allen Bradley, and I had a Siemens S7 315. In addition, I had a Beckhoff PLC that I had intended to wire in later, but everything was switchable by means of cables. You could unplug cables from one part of the simulation and plug it into a different PLC. It had a variety of features. It had an indexing conveyor that would carry boxes into a pick and place. It would load small balls into the boxes, pick them up, place them on a dial table, where the dial would move under a camera. The camera would take a picture of the balls and make sure that the balls that were dispensed were what was supposed to be in there. And this was used for programming recipes, doing part tracking, and learning how to program the different types of subroutines that belong in a well-structured program. Unfortunately, the mini factory was destroyed in a tornado about a month and a half ago. But I also used some small imitation factories made by Fisher Technique. Before the tornado, I had bought several of these models and had also bought some extra parts, and unfortunately they also were destroyed in the tornado. Several of them are salvageable, and I've spent a lot of time cleaning up the components, but I hope to get back on interfacing with these a little bit later. These small trainers are significantly less expensive than the large extrusion-based trainer, and another advantage is that each student can have their own, and it has the same approximate amount of I/O that the large trainer did. I'm currently in the process of redesigning the cable assembly so that it can be sold separately from the Fisher Technique trainers themselves. In addition to the hardware trainers, this is a simulated software trainer. This takes a little bit of technique. The general idea is that you can write a sequence, as is shown here, typical sequence as is in my book, Advanced PLC Hardware and Programming. It shows how to build a sequence like this. We then use this summary and then drive outputs. Up at the top here, this is a little artificial HMI that I use with a no-op. And if I push the button here, you will actually see this operate. You can see the conveyor running, and you can see it stepping through the sequence, some of these different numbers changing, and the inspection's all done. I use a few interesting features here. The same HMI is up at the top of the simulation routine. The simulation routine contains things like this random number generator, which generates a random pass and fail based on whatever number percentages you want as a result. This is also in my book. You can see here that I have aliased inputs to a generic structure, sim inputs. I've also aliased outputs. So with this type of programming, you can let an output run a timer and then make the corresponding input answer back to it. This runs in a separate routine and interfaces with this inspection logic. Take a look at this auto sequence and watch it step through. When I push the button, the part present sensor shows up. Everything moves. You get either a pass or a fail. You can see the steps changing here. And eventually it stops running. There's quite a bit of logic that's involved with this, and I will do a further analysis of the simulation in a later video. But I've used this in my last several classes. It's been pretty useful to let students watch their routines run. All you really need is the PLC itself. You don't need any hardware. Ideally, rather than just this operator interface to see the status of the different signals, ideally you would also like to see things move here. So this is a conveyor with a little reject cylinder on it and an inspection camera. It would be nice to have all the graphics for this, but unfortunately that would take another setup in software, something like Factory Talk, ME running on the same computer. That's pretty much everything I wanted to say about simulation. Thanks a lot for checking out my video.